Adam from Atomiq, which is one of the key sponsors that we have here in the Starknet Hackathon. And I'm very, very happy to say that I think a lot of you are going to be using Atomiq either you want it or not. Atomiq is such a crucial piece of infrastructure for us to build with Bitcoin and Starknet that, I mean, it's inevitable. So yes, and so Adam, the workflow is like this. Feel free to talk. We have around 30, 40 minutes, 45 minutes, as you wish, as you prefer, no problem. We'll be recording YouTube. I will send whatever is said here. I will send the link to the resources of the hackathon, so everyone can see it, even if they don't came. So all the links, Adam, that you will post here in the chat, I will also send it to the resources of the hackathon. And any questions that we have here or in YouTube or in X, I will give it to you, Adam. I will interrupt you a couple times during the workshop to ask you some questions. And yep, that's the workflow. Any question, Adam, before we can start?
Okay. Yeah. No. This is all good. Sounds good. I will just share the guest I wrote for this session specifically. Or there is like a bunch of things and links and resources.
Excellent. We got here. We will share it to everyone here. We will share it in the resources of the hackathon. So please go into the dev post webpage. You know, where you register for the hackathon. There's a link to go in the main page. You will find a link to join the Telegram group. I think most of you are already in the Telegram group. Or either way, in the Telegram group we have a channel called Resources. In there you will find everything that Adam will be sending here, and also in the support and the technical support channel, you will be able to tag Adam if you have any questions regarding Atomiq. So okay, sorry, Adam, the floor is yours.
No, great. Okay, yeah, thank you. Yeah, it's awesome to be here. So I'm Adam. I'm leading the tech side of Atomiq. I'm the co-founder there. And with Atomiq, we basically have an SDK that allows you to easily onboard Bitcoiners into Starknet, but also go the other way around. So you can also go from BTC into Starknet tokens and from Starknet tokens into Bitcoin. On one side, we support Bitcoin L1, so the main chain, but we also have support for this Bitcoin L2 solution that's called the Lightning Network. That's kind of quickly becoming this kind of connective piece between all the different kind of L2s and other kind of scaling and other solutions that are built on top of Bitcoin. And so today we'll go through a live coding session together where we create a script that will be able to swap between Starknet and Bitcoin assets. We'll first do the on-chain swaps, so go between Bitcoin L1 and Starknet. And then later on, we will also try the light network swaps if there is time to do that. So without further ado, I would start by sharing the screen here. Oh.
We got already, I mean, Adam, while you look for that, don't worry about the questions. I will be redirecting them to you. So while you look for what you're going to be sharing, there's a question by Kalim. He says, so we choose to use the mainnet or Lightning Network, or that is handled via the SDK?
Yeah, we will go through that. I just have trouble sharing the screen. I'm getting an error code there. Wait, okay. I will try to just restart the Zoom meeting and see if that fixes that.
No worries. We'll wait for you here. So guys, now that Adam is not here, you need to choose between Garden and Atomiq, I think. Both are amazing technologies, to be honest. Using atomic swaps, which is a huge technology right now that we're using. So yes, we got a couple options already for you. Atomiq is an amazing company. Garden is also such. If you want to watch the Garden workshop, it was yesterday. You will find it in YouTube, also in the resources. And yes, Sergio, indeed, both are using atomic technology. To be honest, I didn't know that Garden was using atomic technology, but it seems like that. So yes, this is very interesting. Both are very trustless, but we will see that in a minute. Yeah. Hey, Adam.
Okay. Yeah, this is still not working.
Maybe let me see if I can do something from my side. Okay.
Does it work for you on your end? Like, can you do a screen
Uh,
share?
let me see. I just changed something. Maybe you can now. Can you try again, please?
Yeah.
Not working yet, right?
No, yeah, still getting some error code. Yeah, but it seems like it's working on your end. There should be a way to join from the browser. I might actually try that.
Okay. Okay.
Yeah.
No worries, Adam.
Good.
All right, folks. So in the meantime, you know what? I'm going to get some water. So give me just 10 seconds, please.
All right. Yay. Great. So web is saving us, it seems, again. Uh,
All right. Oh, it worked. Perfect.
nice. Yeah. Okay. So we'll like literally start with a completely new project. And so, and here are the notes. So here are just some useful links on top. We'll need them as we go through the steps here. So this example will be done in TypeScript. So if you don't have TypeScript installed, just get it with this first command. I already have it, so I will just skip it.
Adam,
Then
sorry to interrupt you. Can you zoom in a little bit, please?
for the wait,
Just
is it too blurry?
yeah, that's better. No, blurry. No, it's perfectly. It's just that it's a little bit zoom out, but now we can see it perfectly. Thank you.
Okay, great. Yeah, okay. Hopefully I can then. Yeah, all right. Yeah, let's care about this later. Okay, so TypeScript, then create basically a new directory. Here we just initialize it with npm init, and yeah, just get through everything. Then for we just create a directory for the source, so src, and then we'll use the following tsconfig file, or at least that's what I'm using. I mean, if you're using something else, I guess it can also work. So here, just copy this in, great. And so now we get into the actual packages that you need to install. So the first is, we can start with the SDK one. So we're gonna install the SDK. Then we need a library that specifically handles the Starknet network for the SDK, which is this one, the first one. We install this one, and then we also need to get this BTC signer for the Bitcoin side of things, and we'll also get the Starknet library version 7 for now. So this currently, our libraries work with the Starknet 7 lib, Starknet.js 7. So that means you still have to use them with RPC version 8. We have the version 9 support in beta now, so yeah, that will come shortly. Now, because the SDK works in a peer-to-peer way, so there's like no central backend where there would be the swap data stored. We need some kind of storage backend for the swaps to be saved to. And for browsers, you don't have to do this because by default it just uses the IndexedDB of the browser. But since we are now like doing an example in Node.js, so in the backend we are not in a browser environment, we need to install this SQLite storage adapter basically for the SDK. So we installed that, and there is also additional like depth dependency when you're using TypeScript for this, and also are in Node.js environment, which we are. So we also get this types for the node. All right. So now with everything set up, we can create in the source directory an index.ts file. And yeah, now we are basically ready to start coding. So we will first do the swaps on testnet because this is completely fine for the on-chain swaps. It's kind of tricky on the for the Lightning swaps because the yeah, there are like literally like no Lightning network wallets that are live on testnet. So we will try that on mainnet then with some smaller amounts. Okay, so let's do the testnet RPCs first. So we have the RPC provider, just a regular. I can maybe try to zoom this. Is this visible enough?
Maybe if you can zoom in, that will be a bit better. With Command plus or Command plus or Control plus, maybe.
Okay, that's not working. Wait.
It's not bad. It's not bad. We can see it.
Yeah,
Just
here it's
you can find it.
on site.
Looks a bit better.
It's Alt Shift plus.
All
No,
right.
that also doesn't work.
In the meantime, there's a question by Kalim. Can we save the swaps to Google Cloud Storage via BigQuery?
Sure. Yeah. So there is exactly. So basically, what happens? What this? So there is a standardized interface for this like storage adapter, and you can basically just extend it and save it wherever you like. You can, yeah, surely you can use cloud providers to store the data in. And this is especially useful if you kind of expect your users to not be on the same device and kind of have like multiple devices using the same wallet. Then you should have something like that with a shared storage space, which is somewhere in the cloud. I will go over that once we like kind of get to a point where we kind of use the storage adapter, or once we pass it to the SDK. But in the meantime, let's continue with the setup. So we import this Bitcoin RPC. So mempool is basically a provider of indexed Bitcoin data. So this allows us to query address balances, address UTXOs, and transactions and other things, which the Bitcoin Core RPC doesn't allow us to. So we use that. And okay, so we have the RPCs ready. Now there are like these kind of scary looking things, but what they do is just load the wallet from. So they either, if the file exists with the key, with the Starknet wallet key in it, they just load that and create a Starknet wallet just from a random private key there. And if it doesn't, so if it doesn't exist, it just generates a random private key. If the file exists, it just loads it. So this way we can have the same kind of key as we like run through multiple restart cycles of the application. So just need to import the relevant things here. Yeah, so this is basically using now the Open Zeppelin account, just a very simple one with just a single private key. If you were to use the SDK in the browser environment, you might do something like this, which basically connects the Starknet wallet object or creates like an account of the Starknet wallet object, and then you can create, then you can basically pass it into this like Starknet signer. The Starknet signer is.
Sorry to interrupt you, Adam. There's a quick question before going on. So the question regarding, can we save the swaps in Google Cloud Storage via BigQuery? Can we do it in Sanity Studio too? Sanity Studio.
Can we do it in what?
Sanity Studio. Sanity.
Sanity Studio. Okay, well, I don't know what Sanity Studio is.
Me neither. Kalim, if you can provide some more details, that would be amazing. Sorry, I think we can go on, and I will come back in a minute.
Yeah. I mean, we are like just in a minute, like we can go over that, like how would you go around like implementing like your own storage adapter if you need to do that. Okay, so yes, so then you take the regular Starknet wallet, which is just this account type. I mean, you can check this is just a regular Starknet JS account type, and you kind of need to wrap it into this Starknet signer object, which is provided by the atomiq library. And this is just to make it easier with to use the signer with all the things that we'll do with it in regards to the atomiq SDK. So we have the Starknet side of things. Now we're gonna add the Bitcoin side of things. And this is the very same thing. Like we just want to have persistency. So we just generate a random private key for the Bitcoin address for the Bitcoin wallet, and we save it. And if it's already saved, we just load it such that again we get the same wallet every time we restart the application. So here we have this single address Bitcoin wallet object. This is like just provided by the SDK as yeah, as like a quality of life thing where you can just simply use that. In general, if you were to use, if you were to integrate this on a front end, for example, you would have Xverse or Unisat or some kind of wallet like that that would do similar things that this object is doing, right? So okay, and we need to here specify that we are using the testnet network for the wallet. Okay, I see we have a question as
Yes.
well.
So regarding the Sanity Studio, Kalim mentions that it's a DB database like Mongo.
Mm-hmm. Yeah. So yes, and that case it works. I mean, essentially, what yeah, I guess what you need is just a database which has indexes. So it cannot be like a simple key value thing because the SDK is also querying based on some kind of other parameters. So if you have something like Mongo, but if it allows, I'm not sure if Mongo allows you like to do NoSQL queries or something. But if that works, then yeah, you can definitely use it with this.
Perfect. Okay. I think we can go on for now, Adam.
Okay. All right. Okay. So we have the Bitcoin wallet, and actually now we can already like kind of run it and see that we will have the Bitcoin address and Starknet address printed out. So we're gonna compile with TSC, and then we're gonna run this. So it creates in the this folder, it creates this index.js, which we can just run it as a regular JavaScript. And here we have the generated Starknet wallet address and Bitcoin wallet address. And if we run this again, it kind of still like uses the same wallet addresses because we have them saved now here in these like bitcoin.key and starknet.key folders, files. I mean, okay. So now what we can do as we have the wallets, we can go to the faucets. So we're working with testnet, so we can use just the faucets to get some funds. So there's one link to the Starknet faucet, which gives you Starknet tokens on testnet. So we just copy the Starknet wallet address here. All right, so it should be there. And now we also do the same with the Bitcoin side. Where we just copy the address here. I mean, yeah, so we can get up to 0.0001. So we're gonna get as much as we can. Great. So that should be there and sending. So on Bitcoin, it might take some time till that's completed, but like a few minutes at most. So okay, so we have that sorted. So now we can go back and we can basically continue with the actually finally initializing the SDK. So what we do first is to create this factory. So the SDK is like done is made in such a way that it can be like modular, such that if you want to have like more chains, so we already support, for example, Solana as well. So you would just kind of here put more like chain specific initializers. But here in this case, we're just using Starknet, so it's just a single one here. We can just as a quality of life thing, just kind of save the tokens to the tokens variable. This basically allows us to access the tokens that we have available. So we can see on Bitcoin, we have the BTC-LN, which is Bitcoin and Light Network. We have BTC, which is the on-chain BTC. And on Starknet, we have Starknet token, ETH, and WBTC. All right. And now we have the factory. So now we can actually create a swapper. A swapper is an instance that will actually allow us to do swaps with atomiq. And now comes the part where these like custom storage adapters come into play. So if you were to just use this in a browser, this kind of disappears, and it's just this because it natively just automatically uses the index DB of the browser. But since again we are working in the backend environment, in the non-browser environment, we need to use this SQLite storage adapter, which we wrote just as an example. And I mean, well, example, I mean, for you to be able to use the SDK in the backend as well. Yes, basically how it works is you have this. So how this is implemented is you have this unified storage interface, and you basically just integrate this or implement this basically in whatever kind of for whatever backend you want. I mean, it could be like Cosmos DB of Azure. It could be the database on AWS. It can be MongoDB. Can be SQL. Can be whatever. So you just basically implement this, and then you can pass it into the into here like so. And there are like two things. There is the unified storage for the swaps, and then there is this storage manager as well, which is like more simple thing where you just have kind of key value store for like other necessary things. All right, but I mean, if you just use this in the browser, you don't need to care about this at all. If you just use this in a back environment, just use this and it will work. But if you want to like really get fancy and want to have like Azure, like the Cosmos DB in the background, you need to write your own connector there. All right.
Thank you, Adam. There's a question, if it's okay with you. So, does the .key stores private keys? .key?
Yeah, exactly. In this case, yeah. I mean, this is just like so this part is basically for the sake that we are just not connecting any wallets to the solutions, and we kind of need to create our own. So yeah, indeed, these files are holding the keys for the simple wallets that we have created. Yeah.
Amazing. We got a couple more questions, Adam, but I think it's better at the end of the workshop.
Okay.
We can go on. Yeah.
All right. Yep. All right. So now we are basically all set to start swapping. We have the first case of swapping BTC to Starknet, which is, I guess, the most interesting here, is to basically allow Bitcoiners to access the Starknet ecosystem. So the first thing you need to do is, I mean, this is an async thing. We're using await, so we need to wrap it inside an async function. So we're gonna do this like so. And first thing you need to do is to initialize the swapper instance. You just do this once. So if you have an application that's like using atomiq, you would just call this init when the application starts, and then kind of like leave it initialized and kind of not having to initialize per swap basis. I mean, here we are just doing a single swap. So we just initialize there, do a swap, and then just stop the instance after. So once we have that initialized, we can actually perform a swap. or we can actually get a quote. So the way this works is there is basically a network of LPs / market makers, and you're gonna say, okay, I want to swap from BTC into Starknet. I wanna pay 3,000 sats, so that's 0.00003 BTC. Here it just says like whether I'm specifying the input or the output. So here I'm specifying the input in BTC, and like an address, the source address and the destination address of the swap. And so what this does in the background, it sends a request, an RFQ request. So that's request for quote to the market makers, and they basically respond with their quotes. So quote is basically a binding. Binding is basically a binding quote that's partially signed by the LP, and it allows you to initiate the swap with that specific LP at these like predefined conditions as were returned in the quote. And even though there are like multiple quotes returned in the background, the SDK abstracts it away and just returns you the best one. So for you, it's just a single quote, which you can then check. Which is actually the next thing, is to check the input and output amount. And you can also print out the fees, which I forgot to include in this example here. But it's right in the example underneath it. But I mean, if you missed this, it's no worries. It's just for you to be able to see the actual fees associated with the specific swap. All right. So now we will see, and we can try to run it again. So we can compile, and we can try to run it to see that this will actually return a quote like this, right? And yeah, so we see we can swap this amount of BTC into this amount of Starknet tokens, and it's basically gonna cost us this much in swap fee, and then the network output fee is actually 0 for Starknet. All right. So now, if we are happy with this kind of quote that's given to us, we can actually start or like send out the Bitcoin transaction that then does the actual swap. So here there's like a bunch of text here, but essentially because we are using this kind of object that's provided by the SDK, we can just do like this simple swap.send Bitcoin transaction and using the Bitcoin signer to do that. But in the usual case where you would use this for on the front end with, for example, Unisat or Xverse or something, you would actually use this. So you can call the get funded PSBT. So PSBT stands for partially signed Bitcoin transaction, and this is a common format for basically saying, "Hey, wallet, please sign this transaction for me on the Bitcoin side of things," and the wallet signs it, and then you basically can pass it back into the SDK, which is exactly what's happening here. So you just call get funded PSBT. You specify the Bitcoin address of the source wallet. You specify the public key. So this is something that all these browser-based wallets return to you. These two things. So you kind of need to pass them in. And then this returns the actual PSBT and the inputs. So a Bitcoin transaction, it's a UTXO model. You have multiple inputs in the transaction, and this is just to tell to the wallet which indices, which actual inputs should the wallet sign. And then you basically, with this information, you can call the API of the wallet, be it Xverse, be it Unisat, and the wallet will then return back to you a signed version of this PSBT. And this one you can then just simply pass back to the swap, and it will actually send it and on the Bitcoin main chain, and you will get the Bitcoin transaction ID from that. So let's comment this out. We'll use this simpler way because in this case we can. And let's continue. So once the Bitcoin transaction is sent, we have this kind of wait till executed call, which basically waits for the Bitcoin on-chain transaction to confirm. This is like not as fast as on Starknet, obviously. So this can take like literally like tens of minutes. Thankfully, on testnet, it's quite fast. So for the sake of this demo, we won't have to wait too long. So at least that's nice. And yeah, so basically you await this. This basically waits till the Bitcoin transaction confirms and the swap settles. And you can pass here this this callback function here, and this is basically then called for every time there's kind of like a new update when it comes to number of confirmation that the transaction has, and the target number of confirmations that the transaction should actually get to be considered final and the swap to actually settle. And then you have like an ETA that's calculated as well and provided by the SDK. So you can use this to give kind of feedback to the user, saying, okay, like we are estimating that you're gonna wait this much for the transaction to confirm, and it has this many confirmations so far of this many. And yeah, this is basically it. So you just await that, and once that happens, you should receive your funds automatically. And we're gonna print out here the output transaction ID of the specific swap. And after that, after we finish with the swap, we can stop the swapper, which because we won't need it anymore here. All right, so we can check that our Bitcoin wallet does have the necessary amount of BTC in it. So I also provided links to the explorers. So one is for Starknet Sepolia, which is the Starknet testnet. And yeah, this is the mempool explorer for the Bitcoin testnet. So we can check our wallet address on the Bitcoin side. And yeah, we see we have some amount of BTC there. So that's great. So now we should be able to just compile this and run this, and it should actually go through and execute the swap. Yep. So we can see that it broadcasted a Bitcoin transaction now. So we can actually check that that happened. And yes, indeed, it's there. It's waiting in the mempool now. And yeah, as I said, like the blocks on testnet are like very fast compared to mainnet, so it's gonna confirm in a short while. But as we wait, we can go through some of the questions. In the meantime, you can see here these are like printed out like that. So there are some updates on the ETA. I mean, the ETA is
Okay. So basically, there's one main question here is, so there's, for what I can see, there's at least 2 people in here.
testnet, obviously. So
Sorry, Adam, can you hear me? Yeah, right. Can you hear me?
yeah, no, yeah.
Perfect. Okay.
Yeah.
So there's 2 teams here at least, and I know of more that are using Chippy Pay. Chippy Pay is basically an invisible wallet. So it allows you to log in with, for example, your Google account, while keeping your self sovereignty of your funds. So it's like what we call it an invisible wallet. It's for applications that don't want to be seen as crypto. So it's beneath that you're using crypto. So a lot of people are thinking about using Chippy plus Atomiq. Any advice on what would be a good workflow for this? For example, Kalim is asking like, so he wants to log in with Chippy Pay, and then Atomiq will be implemented in the same flow. Actions, sorry, just a second. Will be, maybe he's thinking about using Xverse also there. So just, what would be your advice on the workflow of using Chippy and Atomiq? Also, there's a question of whether to use Atomiq or Garden in here. So if you can give us a couple answers in there. Also, please, Kalim, if you can tell me a bit more details, if you wish, and also Sal, if you want to give me some more details that I can ask Adam, that would be perfect. But yes, I don't know, Adam, if you understood the question, but
Yeah, no, for sure. I mean, it kind of depends. It kind of depends on what you want to accomplish. It's certainly like possible, and I think that's a very good way to look at things is to like kind of abstract away the Starknet part there, especially if you want to do something for BTC-Fi. Even the challenge that we have in the hackathon is focused on to make it very simple for Bitcoiners to come into Starknet without even knowing that they are on Starknet, right? So exactly kind of what you say, like you use an invisible wallet in the background. So for the user, it seems exactly like a centralized exchange or something. He can go in with his BTC. He can then do things like whatever you want him to do on Starknet without knowing that he's on Starknet, and then he can once he's done doing things there, he can just go back on the main chain or on the Lightning Network, right? So that's definitely possible and doable, and I would love to see a solution like this. When it comes to the differences between Garden and Atomic, I mean, so from the technical standpoint, it's that we use a different kind of primitive for these trustless cross-chain swaps. We don't use atomic swaps or like the HTLC atomic swaps in that Garden uses for on-chain swaps, because we deem them that they have like some inherent issues. First is the liveness required from the client. So if you're gonna go from Bitcoin on-chain to Starknet, it's kind of like a bad experience if you require the users to kind of stay online until their Bitcoin transaction confirms. And this is something that you need to do with Garden. With our solution, this is not required. So you can actually have a user send the Bitcoin transaction and then close the browser and or like the application, and the swap will still go through and settle automatically. And this is especially important when you work with Bitcoin, because I mean, you have at sometimes you literally have like 2 hours there is no block, and just imagine the UX of that, of the user having to have the app opened to till that point, right? So this is something that's kind of better with Atomic. Another thing which I actually didn't have in the notes here, but what you can do with Atomic is basically if you swap from BTC to Starknet. I mean, here in this case it doesn't make sense because you're swapping to a native token. But imagine that you're swapping from BTC to WBTC on Starknet. Now the issue is you get WBTC, but you get no kind of Starknet tokens to transact on Starknet, which is a bit of an issue because as far as I know, if you want to deploy an account, you actually need to do it without a paymaster. I'm not sure if that's still the case, but was until recently, I think, was the case that you kind of couldn't use a paymaster to deploy the account. But maybe that's better here. So basically, what Atomic allows you to do is with the WBTC token, you can also get a little bit of Starknet tokens, such that you have then a native token to pay for gas on Starknet, right? Yeah. So I would end it at that basically.
Thank you, Adam. That's extremely useful, extremely useful. So, for the moment, there's no more questions, but I'm expecting some more questions in the Telegram regarding this integration with Chippy. But I will share what you just mentioned about, and yeah, hopefully.
Yeah. So essentially, if I mean, Chippy should actually expose something like this. So you have this wallet account for the browser thing, but you should also have this account object of Chippy. You would just pass it here into the Starknet signer, and then all things should just kind of work as they are right now with the Open Zeppelin account. Yep. So I mean, now we can see that the swap went through. It actually went through quite fast. So we have this transaction which we already checked on the Bitcoin side, where I sent like 3,000 sats. This output here, and here is the Starknet side of things, which we can check here on Voyager. And yes, here we see that we received the Starknet tokens on the Starknet side. All right, so okay, so this basically concludes the swapping from Bitcoin into Starknet, and now we can do it the other way around, which is also like a straightforward. So I will just remove this middle part and leave the initialization and the stop as is. And now we're gonna go through this flow. So Starknet to BTC.
While you do that, Adam, just a reminder for everyone that I will be sharing this link to the repo in the resources, all right? So you will be able to see this.
Yep. All right. So okay. So now we are swapping from Starknet token into Bitcoin, into L1 Bitcoin. Here we also have this kind of again like a quality of life function, which basically is able to parse a human readable amount, because usually just pass it as a I deleted it now, but for the Bitcoin case, we passed it in like base units, which is satoshis. So this would be like, yeah, not as nice for Starknet tokens because it would have just a lot of zeros. So here we are using this like quality of life function that is able to parse a string amount, and you just pass which token it's in, and it just returns you the actual amount in the base units. So okay, so amount, then the again we are specifying exact input. So we are going to swap 15 Starknet tokens into BTC, and again we pass in the source address and the destination address, and here, and again we can just print out the amounts and the fees. So now compile, and now we can run this and actually see the amounts. Yes, so we are swapping this much Stark into this much BTC, and these are the associated fees with that specific swap. And yeah, so now if we are happy with the amounts, we can actually go through and with the swap. So as I said, like if you have the account kind of object of for example GPPay or whatever else you would want to use, you can just like down here you would just wrap it into this Starknet signer object, and this allows you to just simply call swap.commit. So swap.commit means I'm committing the funds, so I'm actually like pushing the Starknet fund on Starknet into this escrow, which will then allow me to swap it into BTC. But again, if you don't kind of want to use this, you can also go this route, which basically allows you to get the transactions that you need to send for this to happen, and you can then just simply execute it with the account. So you can just call account execute or account deploy account. So usually you would just have kind of the invoke transaction here, but if it's the first interaction that you're doing from an account, you will the SDK is like smart enough to push a deploy account transaction here in the transactions as well. So that's why there's kind of this like ifs here. All right, so okay, so either use this, which is simpler, or if you want to have like more granular control over like sending the transactions, use this side. But here, be careful. You need to kind of call this swap wait till committed, such that the SDK actually waits, such that you wait till the SDK actually detects that you did initiate, you did commit, you did initiate the swap, basically, right? So there is that. So okay, so now you have the starting transaction sent. Now comes the part where we wait for the actual payout to happen on the Bitcoin side. So the way this works is it waits till the Bitcoin transaction is sent, or if the other side, if the LP basically either refuses to proceed or just kind of basically if he refuses to proceed, you will get the success false here. And what this allows you to do is to refund funds back to yourself, right? So this is kind of the way how we achieve atomicity of the swap. So if the LP refuses, you can just refund the funds on the Starknet side back to you. I mean, this usually never happens. It's just, you should have it just for the SDK to kind of stay trustless for you to be able to refund in case something fails. And that's it. So we can then basically just print out again the transaction ID on the Bitcoin side. All right, so we can check first if we have some balance on the starting side. I mean, we should have. We did get some from the faucet, and we see yes, so we have some balance here. So it should be plenty to do a swap of 15 Stark to BTC. So okay. Okay, so seems like the yeah. So this is just something that happens from time to time on Starknet Sepolia, that you have kind of an L1 data gas fees going to Stratosphere, and then we kind of have a sanity check here to not pay too much. But I think you can somehow, you can override this. So usually you wouldn't have to do this on mainnet. This is just because.
I mean, in the end, I know what the chippy people will tell you. Just test in mainnet.
Yeah, right.
Like that.
I mean, we will do that with Lightning probably, but yeah.
No, it's okay. No, I understand.
Let's do some higher amount, like so. Okay, so hopefully this should resolve this. Wait, I need to compile. Oh. So, okay. Oh, now we're getting very low max prices per unit. Oh, of course. I mean, we're just passing in one here. Okay. So now this should actually work. Okay, yeah, so now I think this is working. So I will where will I send it? I will just send it here in the chat, so you can pass it into the swapper constructor and use it. Oh, okay. Okay, yeah, no, it went through. Great. Okay, so again, just some issues with blast RPC. But okay, so it went through. So what happened is that first it sent a Starknet transaction here, which we can check, which put 15 Starknet tokens into the escrow, and then on the other end we got Bitcoin out on the Bitcoin network here, and it's already confirmed, right? So this first output is basically ours. All right. So okay. So that basically concludes swaps to and from on chain. If we have any questions, we can go over them now.
Yes, we got a last question here, Adam. So this Sergio mentions this looks way more pragmatic than Garden. No secrets, no need to have both wallets from both sides. That is Alice and Bob, right?
No way, no need to what?
To have
Wallets?
both wallets from both sides.
I mean, you kind of do need to have wallets of both sides, right? Because you need to somehow send the BTC in, or what is meant by that? Yeah, I know. Like you still need the yeah. You still need at least the source wallet, right? So actually, if you wanna go from Bitcoin to Starknet, you need to have the Xverse or Unisat wallet or something that can like sign PSBTs. But then you don't need to have the destination wallet connected per se on the Starknet. So you can just send to address basically. And the other way around is the same. So you only need to have the Starknet wallet that can sign transactions, but the Bitcoin wallet you actually don't need to have. You just send to an address. And with the secrets, yes, I mean you're right. So because of the way we handle on-chain swaps at Atomiq, there is no secret like with HDLC swaps for Garden.
All right, those are the questions, Adam. However, if someone else has questions, please ask them in Telegram. There is the support channel. You can tag Adam in there. You will find his Telegram in there.
Yep. All right. So I mean, I had the Lightning swaps as well here, and I guess we can just quickly go through them. There is not much time, but I will just like quickly showcase how that's done. So for Lightning, we are unfortunately forced to use HDLC, so you kind of have to like mess with secrets there, unfortunately. So okay, what we're gonna do is we're gonna switch this to mainnet because, as I said, Lightning on testnet is like, yeah, you cannot really find any wallet whatsoever. So the Bitcoin wallet we actually won't need anymore, so we can just remove that. We'll just use the Starknet wallet, and you just use an external Lightning wallet to pay for stuff and receive stuff. Okay, so this here we just set it to use the Bitcoin mainnet network. This we shouldn't need because now we are on mainnet finally. The key we can use the same. All right. Yep, good. So now I will remove this part. All right. So okay, so let me check the addresses. So, okay, so this Starknet address, I will send some funds to it from my Bravos. Okay. All right, so here, yeah, basically sending 30 Starknet tokens. Okay, yeah, so that's done. Okay, so now to test, we're gonna use this Cashew wallet. So as I was talking in the beginning, that Bitcoin is kind of disconnecting piece between all the different scaling and other technologies on top of Bitcoin. This is actually not the Lightning wallet. This is what's called an eCash wallet. it's a custodial solution, but it provides like a great level of privacy. I think there is like one project on Starknet that also is building such a thing as well. However, I'm not exactly sure the name now. So yeah, so this is what I also left the link for in the notes, so you can actually also use it by clicking the yeah here. I mean, yeah, I will need that. Okay. Yeah. So I have that now, and yeah. So I will just quickly copy the snippet that allows me to go from Starknet to BTC Lightning. So this part. So as I'm using an external wallet, I will basically need to paste in this Lightning Network invoice, which is kind of like an address, but I can add an amount to it. So I'd say I want to receive 1,500 sats. I create the invoice. Now I can copy it, paste it here. And now when I run this, it should actually pay out the Lightning Network invoice. So it's sending the Starknet transaction that locks up the Starknet tokens. And yeah, as soon as that confirms, then the Lightning Network payment is initiated, and then the kind of the secret, the pre-image, the Lightning Network payment can then allow the counterparty to unlock the escrow on the Starknet side, and this is how it's kind of ensured that like the LP can only take your funds once he actually pays out the Lightning Network payment. So as you see, we successfully swapped from Starknet to the Lightning Network wallet, and now we can also do the other way around, which is here the last case. So I will just replace this again. And yeah, so this is for now something which actually doesn't have that great of a UX, and we're actually right now working on improving this. And like, yeah, it's probably gonna be live in a week or two, because currently what you need to have to receive the Bitcoin Lightning Network payment, you need to have a funded account on the Starknet side and on the first place, which is not so great for the UX. And the reason you need to do that, because you need to actually be able to send the transactions to claim the Lightning payment on the Starknet side. I mean, yeah. Long story short, bad UX. We're working on improving that, and should be much better in 1 to 2 weeks. But now this doesn't pose an issue because we still have some Starknet tokens in this wallet here, so we should be able to just compile and run it. And we're gonna get this Bitcoin Lightning Network invoice again, which is like an address we had sent here, Lightning, pasted in here, and hit pay. And yeah, now it should be paying. Just takes a bit of time, but yeah, in a short while we should actually be able to see here that we received the funds on the Starknet side. Yep. Oh yeah, I actually forgot to copy the last line, which would log the output transaction ID. I mean, just rerun it. Okay, but I mean, as I'm rerunning it, if there are like any last questions, I'm like happy to answer them.
Sorry, there's no questions for the moment. No.
Okay. Yeah.
There's people saying that they love the workshops. That's right.
Nice. Awesome. Yeah. I mean, honestly, like this is like me first time doing this kind of thing, so
That's
I was
very good.
also a little bit nervous. So yeah, it's great that people really liked it. Okay, but yeah, now we can see that it was settled, and there is a transaction ID on Starknet printed out, and we can now just check it in the Explorer and see. Wait. Oh, okay. Yeah, sorry. It's on mainnet, so that's why we didn't see it here. Yep. Right. So yeah, we can see that we received the Starknet tokens basically here. So yeah, there is no Explorer for Lightning, so we can really just showcase the Lightning payment. It's Lightning Network in and of itself is a little bit like more private because it's an off-chain protocol. So you don't have like a block Explorer where you like immediately see all the transactions. So that's why it's also kind of nice to use also from this privacy point of view. Okay, but yeah, I mean, if anyone were to have like some questions when it came to the SDK, just feel free to reach out. So the best source when it comes to atomiq SDK, it's just atomiq Labs. It's just our SDK page on npm, where we have basically a way how you can do swaps. And like, yeah, there are snippets, like kind of exactly what we just went through here at the workshop. And we also have the example file here on GitHub, which basically contains all the different swaps that you can do and all the different. So there's also like a bunch of other things you can do with the SDK, and there's also a lot of utilities that you can use. So there is like a general purpose address parser, which can tell you if the address is Bitcoin, Lightning, LNURL, which is then an extension of Lightning, or if it's a smart chain address, in this case either Starknet or Solana address. And then you have all the different kind of swap directions outlined here in a separate function. So this is really like a great place to just check how things are working and just take something as an as a base and then kind of adjust as you need it.
Perfect. All right. So now you know people how to get in there. And any further question we can ask Adam. And I think it was an amazing workshop. Great feedback from the audience, Adam.
Yeah. All right. Okay. Yeah. Loved it. Okay. So see you guys, and yeah, feel free to reach out.
Thank you very much, Adam. Thank you very much for your time, for your knowledge, and well, let's go hacking. See you guys.